Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Good afternoon, everyone, and welcome. My name is Kim Ricketts, and I manage, along with Kirsten Wiley, the Microsoft Research Visiting Speaker Series. Today, we welcome Dr. Greg Burns to Microsoft Research. He's going to begin with an introduction to neuroeconomics, and we're going to end up talking about Iconoclast, which is the book that he's here to discuss today. He just thought it might be fun for us to take a tour through the wonderful and fascinating neuroeconomics field. And in the end, we'll have lots of Q&A, as we always do. Dr. Burns graduated from Princeton University with a degree in physics, received a PhD in biomedical engineering from UC Davis, and an MD from the University of California, San Diego. He completed a psychiatry residency at Western Psychiatric Institute and is currently the Distinguished Chair of Neuroeconomics at Emory University, where he is also a professor in the departments of psychiatry, economics, and the business school. Much of his current research is in human motivation and decision making, and we're thrilled to have him here at Microsoft Research.
Thanks, Kim. Well, it's great to be back. This is actually my second time here, but first time in this building. And I'm trying to look out, see if I recognize any people from the last time, which was about 3 years ago. So at the last minute, I decided to give a different talk for you guys, more or less just based on past experience coming here. The Iconoclast talk is, I think, a little too lay, shall we say. And this is really, this talk, the introduction to neuroeconomics is, like the subtitle says, is really kind of the prelude to the book I wrote. Because I started thinking about iconoclast as the field of neuroeconomics was evolving. And I checked with Kim to make sure that you all haven't had a talk on neuroeconomics before. And so hopefully this will be interesting. And at the end, we can talk a little bit about iconoclasts and what the implications from neuroeconomics are and kind of how we go to talking about innovation specifically. So I always start with this slide, introducing neuroeconomics. So neuroeconomics is a new field. It's roughly, I would say, about 5 or 6 years old. Really kind of started got going around 2003 when a group of about 10 neuroscientists, and I was in the neuroscientist camp at that point, got together with a group of about 10 economists, and Dan Ariely, for example, was one of the folks on the economist side. And we got together for a weekend to discuss the possibility that, in fact, we're talking about the same thing, which is human decision making. And it was a very interesting and frustrating weekend, as I recall. What happened was the neuroscientists got up and they started talking about things like dopamine and reward, and the economists got up and started talking about things like value and utility, and nobody knew what anyone was talking about. It was literally a clash of cultures, and one of the economists, a guy named Aldo Rostachini, got up. I remember he's Italian. He's very kind of emotional. He said, I don't know what you guys are talking about. I don't even know that this is worth doing anymore. And I recall actually in the previous year giving a talk at Princeton, which was even kind of predating neuroeconomics by about a year. Danny Kahneman was in the audience, and this was just about 6 months before he won the Nobel Prize. And he was sitting there, and he was hearing all these neuroscientists talk, and he too was skeptical. And he said, I don't know that this is going to help us understand human decision making. He has since, I think, changed his mind about that. So long story short, what happened was it was created out of a need to understand how people make decisions, recognizing that economics has a very limited tool set, which frankly has substantial weaknesses to it in explaining human behavior. And the idea is by peering inside the brain, maybe we begin to understand decision making from a much deeper level. It also turned out that it works top down as well. Not to disparage economics completely, the thing that economics brought to the table in terms of neuroscience, which neuroscience is completely lacking in, are theoretical models. So neuroscience, pretty much like all of biology until recently, has been fundamentally a descriptive science. Lots of data, very short on theories. In fact, really the only theory that anyone agrees on is Darwin's theory of evolution. And beyond that, it falls away very quickly. So the appeal to neuroscientists like myself was that economics actually brought some quantitative theories. The fact that you could start talking about decision making and write down equations that describe decision making, and then go into the brain and start looking for correlates of parameters in those equations is extremely powerful. It gives us tools to start interpreting this wealth of data we collect. And the field's still evolving, but what has emerged is a common language, at least now, that we all understand. Now, this slide simply illustrates the fact that you can talk about decision making at many different levels. Most of the time, we talk about individual decision making, fairly trivial decisions, like I'm going to buy this or buy that, or I prefer red over white wine. And neuroeconomics really lives kind of in this realm here. It talks about what systems underlie these decisions. Now, it's also extending kind of into group behavior, which is very interesting. And this is actually kind of where Iconoclast came from and got me thinking about this, which is, how do we begin to understand how people behave together in groups or in pairs? And what is specifically the biological link between these types of decisions? The fundamental argument that I make in Iconoclast is that as social creatures, we have, depending on what figure you believe, anywhere from 10,000 to 100,000 years of evolution, recent evolution in the human brain. And all of that evolution was in the context of social groups. It still is. And, if you think back 10,000 years ago or 100,000 years ago, a human or a proto-human, if he didn't belong if he wasn't part of a group, if he wasn't part of a community, pretty much he was dead. Certainly he didn't reproduce. And so what the brains that we have today reflect that. It reflects the fact that our brains very readily incorporate the opinions of the group. And it will sometimes do so to the point of discarding its own processing of what it's seeing. And this presents a challenge, obviously, if you want to do something truly innovative and truly iconoclastic. It's extremely difficult. And so much of what I became interested in was just simply reflecting the very practical, pragmatic problem as a scientist. I, like you all, struggle with the fact that you want to do something or you need to do something innovative, discovering something new, but you still have to bridge the gap between discovering something and then actually convincing other people of the merits of that idea. And somewhere in there, many things get lost, and probably 99% of ideas and discoveries get lost. So all of this had its origins really in neuroeconomics. And I just point out the fact that this is really a closed loop. We can talk about genes in terms of behavior, but frankly, there's too many levels, I think, to make a lot of sense out of that. Genes don't code for behavior, despite what people will publish. Genes code for proteins, and proteins make cells. So there's many levels to span here. But it is a closed loop, because the decisions that we make in groups govern reproductive choice and then guide evolution. Okay, so on to neuroeconomics. What are these folks doing? Well, no, they're buying stuff, but the convenience store, the crowd, the expressions of expectation should be the dead giveaway, actually. Lottery tickets. So lotteries in general are great. This is kind of the standard paradigm of microeconomic decision making. And the fundamental question, which every economist has really tried, every microeconomist has tried to grapple with, is why do people buy lottery tickets, right? You can flip the ticket over and see what the odds are. And generally speaking, you know, if the odds are, say, 1 in 100 million of winning, and it costs $1 to buy the ticket, it's irrational, at least from an objective point of view, to buy a ticket unless the jackpot is worth more than $100 million, right? The expected value of the ticket has to at least be greater than the cost of the ticket. Yes?
I don't know if it's irrational, because even if on average you're behind, it's a life-changing event. So playing Keno might be irrational, but playing like the big ticket lotto might not.
Right. So let me breeze through kind of the usual explanations for this. I will point out, however, that there is a dramatic disconnect between expectation and reality. This is Andrew Whitaker. I believe he still holds the record for the single largest payout in U.S. history, $315 million. What's really interesting to me about this picture is his expression. If you contrast that with the lady's expression in the previous slide, this is his wife. This is his granddaughter. She died a year later of a drug overdose. His life has pretty much been miserable since winning this lottery, and he's been in the news a lot about it. I believe they're divorced now. The moral of the story is that things are not always what you expect. Now, the reason I tell this is because economic decision-making, in fact, any decision-making, is really based on what you expect. Its relationship to reality and outcomes, whether you actually get what you want or not, is after the fact. That's more an issue of learning and what you do with that information. But as far as actual decision-making goes, the only thing that really matters is your subjective perception of what you're seeing and how you process that information. And it could be completely rooted in fantasy that governs your decision-making, but that is what matters. And so this kind of gets to the heart of why people buy lottery tickets. So neuroeconomics is based primarily, methodologically, on neuroscience methods, primarily brain scanning, functional MRI, a little bit in the way of animal models, but I'm not going to talk about that. It's focused typically on what's called microeconomic behavior, which simply means the decision-making of typically one person. And then within that, there are several kind of sub-genres of decision-making that become very important, and that is, how do people value things? You know, what metrics of valuation do they have? How do they use that to make decisions? And then the interesting area of games, game theory. How do people make decisions when there's at least one other person involved and the outcomes depend jointly on what more than one person does? Macroeconomic behavior is becoming increasingly relevant, although neuroscience is just beginning, I think, to get into this area. And I will talk specifically about conformity behavior because this is what the seed was for me writing this book. This has clear implications, especially with current events in terms of market behavior as well as politics. Okay, I just put this up. I put it up in part because I feel an obligation to, but then I disparage it. I don't believe in it. But Freud did say this was his idea of how people make decisions based on the pleasure principle. He said that the id pursues pleasure and is the source of all internal conflict, that you have the id, and you have the ego and the superego, and these parts of the psyche clash with each other. I think it's cute, but not particularly helpful. I'm actually more intrigued with what this guy said, Jeremy Bentham. Bentham is known as one of the utilitarian philosophers. He was a weird guy, frankly. He founded the University College London. And you notice down here, can you see this? That's his head. What he did, I'll tell you scientifically what he did, but I like this story because it illustrates his peculiarity. After he founded the university, he put in his will that he wanted his head preserved. And the reason he wanted it preserved was so he could be brought out to the annual faculty meetings in perpetuity. And for a long time, in fact, after his death, the college did bring it out, and he was recorded as being present but not voting. I'm told now, though, that the head is safe away in storage. I think it had an unfortunate tendency to disappear, which was usually attributed to the undergrads. But this is, that's Bentham. What he said, this actually predates Freud. It's actually very similar to what Freud said. It was Bentham who talked about utility, and this is key to all economic theory. He says the principle of utility is meant that principle which approves or disapproves of every action whatsoever according to the tendency which it appears to augment or diminish the happiness of the party whose interest is in question. So in modern English, what he says is that we have in our heads this idea of utility, which roughly equate it with happiness, and that whatever we do, all the decisions that we make are geared to getting more utility, more happiness, or to at least diminish the opposite of it. What's interesting about it, and this was discovered by Daniel Bernoulli, a Swiss mathematician, actually even before Bentham wrote it down, was that the idea of utility or value has diminishing returns. And this, he formalized this in something called the St. Petersburg paradox. What that basically means is that if you're talking about money, you get less bang for the buck the more money you have, right? So I think we kind of subjectively know this, that if you have absolutely no money, simply handing someone $10 means a great deal to them. Whereas if you have $100, $10 doesn't mean as much to you. Even though, and this is the paradox, that objectively $10 is $10 and buys exactly the same amount of goods and services. But people don't have that as a subjective response. And this is often invoked to explain the fact that people they do not behave, quote, rationally, or at least objectively rational when it comes to money, because this type of curve means that the more you have, the less you stand to benefit by gaining. And another way of phrasing it is, if you're out here and you stand to lose, say, $50 or 50 whatever, there's more to lose than you stand to gain in the opposite direction. And that's the usual explanation for why people are risk averse. How do you measure this? Well, one way is you can ask the people how they feel about things. That's called experiential utility. That's generally not great. I mean, it gives you kind of an instantaneous measure. The way economists like to talk about it is in terms of decision utility. So you actually kind of infer how much utility people get by looking at what they buy and what they do. You can give them forced choices. You can set up experiments to see how much they're willing to pay for various things using different mechanisms like market price or auctions. And then neuroeconomics comes on the scene and adds to the party neurobiological measures. One more kind of theoretical thing to add about utility theory. After the 1900s, after the 1800s, these two guys, Morgenstern and von Neumann, extended the theory in a very fundamental way. They said that people, in fact, do take account of the odds of things. And what they do is, if you're given an array of choices, each with different potential utilities, people also factor in the odds that they will actually obtain those outcomes, the probability times the utility, and they actually try to maximize this quantity. And that is essentially the foundation of modern neuroeconomics. John Nash modified this theory or extended this theory to account for how people make decisions when the outcomes involve another person, one of the founders of game theory. The final two key figures in this picture are Danny Kahneman and Amos Tversky. He won the Nobel Prize for this. He would have had he not died at a young age. And what these guys pointed out was that not only do people kind of distort value in kind of this diminishing fashion, but it's asymmetric. And that if you stand to lose something, this figures more prominently for a given amount of money than winning. So they have this asymmetry here. It's called loss aversion. Generally, people are more afraid of losing an equivalent amount than the potential benefit of gaining that. He also pointed out that people tend to view gains and losses from kind of whatever their status quo is, not in kind of any absolute sense. They also pointed out, this is a picture of how people distort probabilities, that people behave kind of very strangely when you give them odds, like on lottery tickets. In particular, people tend to overestimate long shots here and underestimate relatively sure shots. And they use this to explain why people buy lottery tickets and then will turn around and also buy an insurance policy. Okay, so that's all background that's the econ background. But I want to talk about dopamine. And I want to talk first about the fable of dopamine, because I'm sure everyone has heard this fable. This is what the chemical structure looks like. Dopamine is made in about roughly 40,000 neurons in the brain, which means that it comprises less than 1% of the total brain by weight or volume. Just a couple of very small structures here that produce dopamine, and they send projections widely throughout the brain. Despite being a relatively small portion of the brain, I assure you without dopamine neurons, you would not be able to get out of bed. And in fact, people with Parkinson's disease have exactly this problem. It's a deficit of dopamine, and they cannot initiate action, and in the late stages cannot really initiate new types of thought or cognitive plans. The popular story of dopamine is this: dopamine feels good. Now, the reason I think this is so commonplace in terms of kind of culture is the early experiments in the 50s and 60s found that if you stick a cannula in a rat and either infuse something like cocaine or you put an electrode in the parts of the brain that release dopamine, and you essentially either pharmacologically or electrically release dopamine, the rat, and you give control of that to the rat will push that bar and, to the exclusion of pretty much everything else. And most scientists of the time assumed that that was because dopamine feels good. Well, in which case it would become the pleasure chemical of the brain. The modern story, which goes back now 15 years or so, is far more interesting. So this is a plot. This was done by a Swiss scientist, Wolfram Schultz. And what he did was he had, these are recorded from monkeys. Now what you're looking at, these are kind of raster plots where each dot represents a dopamine neuron spiking. And you sum up these. This is time going this way. So you get kind of this running histogram that tells you what's happening as a function of time. What these monkeys were doing, this was basic, just classical conditioning. In this slide here, what happens is, at this time, R stands for reward. The monkey gets a squirt of juice on its tongue. And what happens is immediately after that, the dopamine neurons spike. Then they go through classical conditioning. So what happens there is CS stands for conditioned stimulus. A light comes on, and then a couple seconds later, the monkey gets the squirt of juice. Okay, so you get the light comes on here, then they get the juice. And what happens very quickly is the dopamine neurons shift their firing from the time where they get the juice, it shifts backward in time to the light. Okay, it's a very important finding because it clearly points out that dopamine cannot be signaling pleasure in the simplistic sense, because if that were the case, dopamine neurons would continue to fire when the monkey got the juice, unless you think that the light becomes pleasurable. But not in the strictest sense of the word, it doesn't. If you withhold the juice, no juice here, you flash the light, you actually see the dopamine neurons have a depression in firing when they expected to get the juice. So what came out of this is that dopamine now is clearly not simply a chemical of pleasure, it's really a chemical that signals anticipation and expectation, which is far more interesting and important for decision making. Because I just said that the thing that governs decision making is not necessarily what happens after the fact. The thing that matters for decision making is what a person expects. And people's expectations are governed by lots of things. It's governed, by things happening in the environment. It's governed by their past experience and their memories. But fundamentally, when something happens or a thought process is triggered that releases dopamine, it puts the person in a state of readiness to do something, either to acquire something or to run away from it. So the takeaway from that is dopamine does not equal pleasure, but it does equal anticipation. All right, so neuroeconomics got very interested in this relationship. So quick run through of brain imaging, what we do. There's two types of brain images. There's anatomical and there's functional. The anatomical views, I'm sure everyone has seen views like this. Typically we present them in three views, kind of either cut front on like this, or cut sideways, or cut horizontally like that. This is this is a fairly old scanner, but you get the idea that there's certain constraints on doing these experiments. It's actually more immersive when you're doing an experiment. What you don't see here is that we put a mirror above the person's eyes, and so they're typically looking out above their head, and then we put a screen at the other end of the magnet in which we can project images from any kind of display you like, and we can give people various response devices too. So when you're actually kind of in there looking up the mirror and then out the screen, it's not very claustrophobic. At least I don't find it to be that way. And I don't think most people do. You very quickly adapt to it and become immersed in whatever it is that we have people doing. In neuroeconomics, there's been a lot of interest in some key structures. One is called the ventral striatum, right here, this kind of clam-shaped structure, but mainly right there. It's the densest, it's the part of the brain with the densest concentration of dopamine receptors. The amygdala, shown in these two views, is closely associated with arousal and fear responses. Now, the way fMRI works is actually much older than MRI. This is a drawing that dates to about 1850. It was done by a guy named Angelo Masso, who invented the blood pressure cuff. He's also responsible for the modern polygraph, which uses a blood pressure cuff. What Masso was doing, he was experimenting measuring blood pressure, and there was this guy here, his name was Bertino. He was a stonemason in the village that Masso lived in, and Bertino had suffered a skull fracture because one of the stones fell on his head. He lived, but he had a defect in his skull. The skin was over it, but there was a defect in the actual bony part. And so Masso actually put his blood pressure device on that part of his skull and measured the pulsations of blood going through that part of the brain underneath that. And then what he had Bertino do is he went through various types of mental tasks, doing arithmetic, reading, saying prayers. And what he found was it made a difference on what Bertino was doing in terms of the magnitude of the pulsations. And this is the fundamental property that we still use today. It's simply the observation that blood flow increases to the parts of the brain that are being used. And it does so in a very regionally specific way. You add to that something discovered by Linus Pauling, and that is that oxygenated hemoglobin and deoxyhemoglobin have different magnetic signatures. Deoxyhemoglobin is paramagnetic and distorts the magnetic field. And you can pick up, you can detect with MRI the relative concentration of these two things. And so you put those two observations together, and that's really all functional MRI is. The pictures that you often see splattered in academic papers and the popular press are summary figures. And the way we make that, and I apologize, but I thought you guys would want to know this, is nothing more than really kind of an elaborated statistical test, a t-test typically, where you basically chop up the brain into a bunch of little cubes, and you get time series, usually captured about once every 2 seconds, but you can sample faster. And so you get these time series at roughly about 20,000 points in the brain, and then you simply formulate statistical models, and the statistical models are based on what happened in the experiment, either things that you varied as independent variables or responses that the person themselves did. And you simply correlate these different effects with these time series. And you can start to disaggregate various types of effects, and you do statistical tests. And the parts of the brain that are statistically significant are typically color-coded hot yellow. So in neuroeconomics, people have become very interested in how value and utility are represented. And I'm just going to run through just a smattering of studies. This was one done by Brian Knutson at Stanford many years ago, where what he did was he had people doing a very simple kind of button-pushing task and varied how much money they earned on each trial. And then so the statistical test then just goes in and looks at which parts of the brain increase the blood flow based on how much money was being offered on each trial. And what you see here is this part here, again, this part of the brain, the striatum, heavy in dopamine. And what's interesting about it is, again, it precedes the actual outcome. So like once you give the person a cue that they're going to win $5 versus $1, then you start seeing activity rise here, and presumably that makes them work harder. We've done experiments using different types of motivating things besides money. We did an experiment where we offered different outcomes of juice and water. Again, same part of the brain. This is a study that Dan Ariely was involved in, having people rate faces based on beauty. And what they found, again, this is an older study, so the quality is less, but basically the same part of the brain responds to beautiful faces and more than average faces. What all of this means, and now there's about 5 years worth of studies from literally hundreds of groups, is that it appears that there is what we call a common neural currency in the brain. That indeed the brain converts to this circuit, this dopamine striatal circuit, representations of value and utility. It's always in the expectation, anticipation sense, but whether it's a monetary reward or whether it's food, something you eat or drink, or whether it's beauty, aesthetics, or sex, it doesn't appear to really matter, but the brain uses the same circuitry to calculate values. And so really it becomes a question of what's the exchange rate between money and apples and oranges. It's not that those are different parts of the brain. And this is extremely useful because it means that we can then go in and start to look at the activity in here and try to get a sense of how people are valuing things, even in the absence of us asking them. So game theory is interesting. I like this slide, Dr. Strangelove. Dr. Strangelove was actually modeled on von Neumann. I showed you his picture before. He was in a wheelchair. He died fairly young of prostate cancer. But von Neumann set up what's known as the prisoner's dilemma when he was working at Rand. And the reason they created this experiment, this was a model essentially to model nuclear conflict with Russia. And the question that they were trying to answer was whether the U.S. should preemptively nuke Russia or not. And so they came up with this weird game. Has people heard of the prisoner's dilemma? So the basic game, this is the financial version of it. Two people play this. In the usual form, you just do this once and then you walk away. And the game is you can cooperate or defect against the other person. And if you both cooperate, then you both get $2. You can put as many zeros on here as you want. It doesn't really change anything. But if one person cooperates and the other person defects against that person, then the defector gets all the money, $3, and the cooperator gets nothing. So there's this incentive to betray the other person. If both people defect against each other, they get a nominal payout, which is less than if they had cooperated. So what happens here? Well, if you're an economist, you will quickly run through this. This is what John Nash did, and came to the conclusion that you should logically take the course of action that is least bad. Okay, this is called the Nash equilibrium, and in which case, and the reason for that is because you have to assume that the other person knows everything that you know and that they know you know. In which case, the only conclusion of this game is to defect, and then both people defect. And it's suboptimal, because had both people cooperated, they both would have done better. That's what economists, if you give this to kind of graduate students in economics, they will do this. If you give this game to people who are not economists, normal human beings, most people will cooperate, even if they don't know the other person. They will kind of take a chance and assume the other person will cooperate. Well, we did a brain imaging experiment of this several years ago to ask the question, why? And the important finding is we observed activity in the same part of the brain, the striatum, which is the dopamine-rich region, when people cooperated with each other, or at least even in anticipation of it, even though that was not the outcome with the most money. Okay, so the activity here was reflecting not only the monetary reward, but apparently, at least we interpret it this way, some kind of social signal as well, the socially rewarding signal that you took a chance and the other person also took a chance and you were both rewarded. And all this does is points out the fact that, again, we have very social brains and that we value these social decisions as much, if not more so, than monetary ones. I will, in the interest of time, I'm going to skip the game of ultimatum because I do want to move on to social information, because this is kind of where Iconoclast got started. And the experiment I'm going to describe to you has its original motivation in trying to understand Nazi Germany. And where you go with this is kind of a matter of speculation. I'll go back in time and just mention Rousseau, who formulated something called the social contract, which is, he said, there is a common good. Anybody who lives in a group has to acknowledge the fact that there are individual benefits, but there are also common benefits. He said that citizens are not always accurate in their judgment about what is the common good, and hence, this is why we have elections. Rousseau talked a lot about this. It's like, so if we're not always sure what's best in everyone's best interest, how do you decide? Well, the best way is to have a vote. And that's a very efficient way of aggregating a group's opinion. And that's what his third point was. The social contract is exactly that, that as members of a democratic society, you reap the benefits of common good, but you also have the responsibility to contribute to it. Okay, this other guy, Condorcet, said something that chips away a little bit at Rousseau's idea. And we don't generally talk about this, but I'm very interested in this, because this says everything about iconoclasm. He formulated something called the Condorcet's jury theorem. And he said, let's say you take a group of people, let's call them a jury, and you say, okay, P is the probability that any individual in this jury will reach the correct verdict. Okay, so then what is the probability that more than half of the jury will reach the correct verdict? This is not making any assumptions about unanimity. You can just have a majority vote. The theorem says that, and this is the key point, if the votes of the members are independent of each other, then the group, this P sub n, will be greater than P. And I'm not going to go through the proof of this, but it's also known as the law of large numbers, that if you take independent observations of something, if you average the results together, you're more likely to have a correct answer. This is the theory, at least. Okay, now, but there's a serious problem with it practically. Okay, so I say, what is the probability of this jury reaching the correct verdict? Well, according to Condorcet, it's pretty good. It's much better than any individual. But here's the problem. I lost the slide. Sorry about that. The problem is that for groups to reach good decisions, the members of the group have to behave independently of each other. That's the point of a group. You bring diverse opinions in, you aggregate their opinions. Once the members start talking to each other, they influence each other, and the independence immediately disappears. And if anyone's seen this movie, I assume most people have, the group can change from being a very efficient aggregator of independent opinions to behaving like a mob. And the question is, well, what can you do about it? Because I think that is group behavior in kind of its worst possible form. So in comes Solomon Asch. So this is back to understanding Nazi Germany. So he did this experiment to try to understand exactly this phenomena. How can essentially, or why does a group sometimes behave worse than any individual member of the group would on their own? So he did this very famous experiment. He would bring in people into a room and say, which of these 3 lines is the same length as this one? Okay? Nothing difficult about it. The thing that he did, though, that was very interesting was that in this room, let's say there would be about 10 people, 9 of them were Confederates. Everyone but one person was an actor playing a part. And what Asch did was he would go around the room, and everyone but the real subject, would give their answer, but they were all cued to give the wrong answer. So they would go around the room, and someone would say C. The next person would say C. And it would go right down the line until it got to the real subject, the only subject in the experiment, and then Asch would measure how often that person would go along with the group, even though the group was obviously wrong. He did this experiment at an Ivy League college, and so the thing that was surprising, because it was widely assumed that these students were going to be future leaders, future politicians, future leaders of Wall Street banks. He found roughly about 1/3 of the subjects would go along with the group once or twice, even though they were clearly wrong. Experiment's been done so many times, nobody even does this anymore. So we did it, my lab did this because I got very interested. Specifically, actually, a patron came to my lab and wanted to support the research. And he came to me and he said, I'm really interested in the stock market because I've made a lot of money going against the market. And then he proceeded to tell me what it feels like to lose his first $10 million. He wanted to know about this, specifically in the context of markets. Well, I said, that's too complicated of a question. We don't even know what the perception, how people perceive, these tickers. How do people perceive this, this Dow going up and down? So let's take it back to what Asch did. So we did a slightly more elaborated version of this. We did something called mental rotation. And this is a screenshot of what people saw on the scanner. We presented these objects, these pairs of objects, and their task was to decide whether you could mentally rotate them, and decide if these are actually the same object or not. And so it was a binary choice. You either say they're same or different. And just in case you're wondering, these actually are different. You can't rotate them to be the same. Then we hired a group of actors. So these are our actors here. I'm at Emory. We hired these from Georgia Tech across town so that they wouldn't know our typical volunteer. They came from the drama club. And they were cued to give the wrong answers on half of the trials. So that's what you're seeing here. And then the subject actually is waiting to respond here. And we specifically measured what happens in the brain when the person both goes with the group or against the group. Now we had two competing hypotheses. Either when the person goes along with the group, they do so knowing that they're doing that. They essentially know what they see, but they choose to essentially squash that representation and go along with the group for the social reward of belonging to the group. The other possibility is that the group actually somehow changes what you're looking at, or what you think you're looking at, changes perception. And we reasoned that those are two very dramatically different processes, and we could use fMRI to tell the difference. So our experiment was actually far more effective than Asch's because the test was a little bit harder. These are error rates. At baseline, if we don't have the group there, it turns out people have error rates between 10 and 15%, so they're about 85 to 90% accurate on their own. if we have a group there, and the group is giving the wrong answer, red, then the error rates jump up to 40%. That's actually split roughly. If you were a male, you were about 60% accurate, and if you were a female, about 50% accurate in that condition. Keeping in mind it was a 50-50 chance to begin with that you would get the right answer. As a control condition, we had a computer giving the same information. And so the key comparison is how do people process information coming from people versus just misinformation coming from an inanimate source. Well, I have to tell you something about the visual system. The eye transmits through the optic nerve, and the key parts of the visual system are actually in the back of the head. Okay, so I'm supposed to say this is a movie that we're queuing up. This is a representation, it's a rotating brain, but the task is actually mental rotation. The orange parts of the brain are representing the parts of the brain that actually just do the mental rotation task without the group even there. And it's by and large visual areas in the back of the head here, and then coming up on top to an area called the parietal cortex. That's just the baseline mental rotation circuit. The blue areas that I've overlaid are the parts of the brain that changed activity when the person went along with the group and the group was wrong. So this is the conformity condition that we're interested in. And the thing to notice about it is that it overlaps substantially with the baseline mental rotation circuit. It's not even in the frontal cortex here, which is what we would have expected had people just overridden their own perceptions. What this suggests is actually that when people are hearing someone else's opinion and they're looking at something, the group's opinion actually creates what we call a virtual percept in the mind. And what we're measuring here is, in fact, the competition between this imaginary percept and the one that's coming from the person's eyes. And in this case, we're seeing the imaginary one win out. So we're actually imaging a competition here. So you may wonder what happens when people go against the group. This is a cutaway view. As it comes around, you'll see kind of a one blue dot there. That's in the amygdala. The amygdala is really the seat of the fear arousal response. And it just underscores the fact that when people actually stood up for their own opinions, it was very likely causing substantial autonomic arousal to do that. Probably a little bit of fear in there as well. Something I think most people know subjectively but won't generally admit. This, like I said, this experiment here is what actually got me thinking about writing this book, Iconoclast. And because I think this experiment captures all the important features of what it means to do something really differently and why it's so hard. So I get up and I usually say that it is really hard to do things differently, and the reason is because we have social brains. On the one hand, it has a bit to do with perception, because I don't have a slide for this, but it turns out that innovation and creativity have its roots in imagination. It turns out there was an experiment done last year, an fMRI experiment, where they compared the different brain regions involved in perception, which is the process of taking, say, visual information and creating a mental image, versus imagining something. And imagination, like we're seeing here, uses exactly the same circuitry. It's like running perception in reverse, which means that it's subject to all of the same problems that perception is. It means that that perception is based on past experience, that we incorporate other people's opinion into what we see, and it means that our imaginations are as well, that we also incorporate other people's opinions very easily, which makes it, of course, hard to do things differently. And once you do, you still have to contend with this fear response in the brain that seems to get triggered when you start to stray off of whatever the norm is. So just to summarize what I just talked about, and I want to leave time for questions to talk about Iconoclast. I talked about microeconomic behavior and a little bit about macroeconomic behavior and conformity. I think these things are beginning to have real implications and applications not only in markets but also politics as well. understanding, how individuals process information is critical to understanding what's going on in finance right now. As many people will tell you, me included, what's happening in the markets is driven, not necessarily by rational valuations of assets. It's being driven by emotion. It's being driven a lot by fear and uncertainty, and it's also being driven by, frankly, massive herd behavior of people who have large amounts of money to move in and out of the market. So, understanding all of these processes, I think, is tremendously timely. But I will, kind of leave it more interactive and Q&A to talk about specifically the book. And I know I'm here to plug the book, but you can buy the book. I wanted to talk about this instead. Thank you. Stunned silence. But
So which is it, the wisdom of crowds or the idiocy of crowds?
Well, so the problem is the wisdom of crowds is usually right, except when they're wrong. More often than not, the crowd is right compared to an individual. Except the problem is you don't, as an individual, know when it is that they're wrong, which I think is exactly the symptom that we have right now in the finance markets. Everyone has had the same information for a year about, the mortgage crisis, the real estate bubble, so on and so on. And in fact, people were saying a year ago this was coming. So it's not like there's anything new out there. It was simply a matter of collective perception that delayed it this long, and now everyone's overreacting. So, was the crowd right? They were right for a long time, but then it essentially became a pyramid scheme. So the problem then is, for the person who wants to go against the crowd, there's a number of things going against that person. One is this kind of the statistical process that probably everyone else is right and I'm wrong. I think that's still true. But then it becomes an issue of risk. If you can estimate that and estimate, what are the odds that maybe I'm right and everyone else is wrong? If you can do that, then you can start to gauge what the potential payoffs are. And that's, I think, where the real challenge is. And most people shy away from that. I think it takes a very special person who has the quality that can kind of keep that fear in check and actually objectively look at, these numbers and, make a decision. The people who do, are very successful, but it takes, huge amounts of courage. Yes?
So you can't really say if someone made the correct decision based on what the outcome was, just on what they knew at the time and whether they were being rational. And can we really say that people today are irrational with respect to the market? Or is the market really valued more than what it is reflected in its price? I don't know if that's generally assumed.
Well, I don't know. It's probably not useful to call things rational or irrational. Probably, I prefer the terminology optimal.
Sure.
Because, rationality is almost a subjective quality based on one's, risk attitude. Rationality is more about consistency.
But isn't optimal based on what happens?
Yeah. Well, you could say that, but you can also do it prospectively. Would you say it's optimal to buy a lottery ticket, when the jackpot's $10 million? I wouldn't.
It depends. I think it's very, very difficult. I remember being a kid and having $5, but I needed $10 to go on a date.
Yes.
So I may be willing to risk $5 at very bad odds because the $5 to me is not very interesting.
Yeah, I agree. That's a very rational judgment, but I would still say it's suboptimal.
Yeah, I just think it's tricky. I don't know exactly what language is the right language.
Yeah.
Because I also think it's unknown, and it's hard to know whether it can ever be known. We don't know today where the market is going to go.
No.
So we can't really say what's optimal. Even if we're wrong, we can't really say if we made the wrong choice.
Well, you can make statements. If we're talking about financial risk taking, that what's called risk neutrality is probably as close to optimum as you can get on average. So decision making where you don't distort the odds, and decision making where you don't distort the value of the outcomes, and you just treat everything objectively as the number that it is. And I think the really good money managers do this, and the really bad ones, are making decisions completely based on, what everyone else is doing.
Or it could be what they, I forget the producer's name, the movie producer said no one knows anything. Maybe that's the case as well.
Yes?
I mean, is unpredictability in the stock market or in politics, more in the stock market because you have a daily fluctuation, is it because at the nexus of or the meeting point of a macroeconomic reality and a microeconomic reality, there is unpredictability? Meaning, I might be a billionaire to whom $1 million doesn't mean anything, the valuation from the macroeconomic side. The herd mentality is saying go against the trend, or it's saying sell right now.
Right.
But I have valued the risk of it in my own mind, and I'm saying, no, I can bet against the trend because I don't lose anything. As in, my needs are still there. I can really gain from this. Contrast that with the microeconomic reality of someone who wants to go on that date, and for them, this is the only means of doing it. Now they're confirming with the herd or going against it because they have nothing to lose. Does that nexus create its unpredictability? Meaning, because different people are viewing this differently.
Yeah, what you're talking about is often referred to as strategic uncertainty. So the difference between the date example and the market is, in the date example, it's entirely an individual decision, and the outcome depends only on your personal valuations, and how you value risk and reward. There's no one else affects the outcome of that. The market, though, like most kind of interesting transactions, involves an uncertainty that is not only the objective risk, how much the market's fluctuating, but what you think other people think of that. And so the payoff then is not just the uncertainty of projecting, extrapolating the past, but you also have to account for what you think everyone else is going to do, which is essentially kind of a positive feedback loop, and probably is what gives rise to bubbles and crashes. Because you could argue that it's rational, to keep buying into, an inflated market just because everyone else does, and that will make money. That's true, and it will. But the thing that's very hard is because of kind of the fragility of it, it's very subject to crashes, and unless you can time it, it's dangerous because,
Yeah, George Soros has coined this phrase, fertile fallacy, which is you buy into the fallacy because it's fertile and it can gain you money, but you recognize it's a fallacy.
I don't know that everyone recognizes that. That's the problem.
To make lots of money.
Yeah.
That's required.
Yeah.
So my point was that because different people with different valuations of the same thing are using the same system, and using whatever macroeconomic indicators they have to make their own personal microeconomic decisions,
Yes.
and their valuation points are different,
Yes.
that in itself creates the uncertainty. I mean, I'm hypothesizing here. I don't know for sure that that's the case, but...
Well, it's not that it increases the uncertainty. It points out the fact that markets can't even exist unless there's a discrepancy in opinion, right? Because if everyone could agree on the value of an asset, there would be no market. There would be no buyers and sellers. The only reason that there are buyers and sellers is because you can have two people looking at the same object and have different opinions about it. That's when markets work really well. That's what they're really good at. The thing that they don't work well for is exactly the situation that we've been seeing when everyone all of a sudden does come to the same opinion. It's like, oh my God, I got to get rid of this. And that's when you get into the positive feedback loop and everyone suddenly has the same valuation or the same opinion of the future, that you have the bubbles and crashes. Does that mean there's anything wrong with the markets? Not necessarily, but it points to the fact that markets behave, this is how markets have always behaved. And either you accept the fact of that's, if you're going to be in a market, you accept that, or you don't go in the market, or you regulate markets so that they don't happen. It's not clear to me that you can do that, because I think the history of markets has always shown that after every time something like this happens, new laws get made to prevent that specific thing from happening again. and then speculators go find some other bubble to create, and it always repeats itself.
Being contrarian actually works.
It can, but it's a risky strategy, and that's the core problem. I mean, do you have the stomach for the risk? I think people often underestimate the risk.
If you look at your example where the rotation was happening, so 60% agreed, but there were still 40% which gave their own opinion. And you gave the example of Germany, and then if we look at the recent market, the number of people who were complying probably is much higher. Someone like Lehman Brothers, most of the employees, they have their 401k and their incentives are also aligned to do the right thing.
Right.
But their agreement with the group seems to be much higher, maybe 90-95% people did not move away from the situation. So what causes people who move away from the situation? What is it that, how are they different?
Well, okay, so I think, that gets more into what I talk about in Iconoclast. So I think it begins with perception, and I actually spent a lot of time talking about perception today. And the stock market's actually a good example of that, because you can have an asset, and the fact that there are buyers and sellers that have different price points means that they have different perceptions of that asset, that they have a different perception of the future value. And so the question then, obviously you can't tell beforehand who's right or not. That's impossible to forecast. But the question is, are an individual's perceptions truly their own, or are they being mixed in with other people's opinion? And that was kind of the whole point of this Ash experiment. And I think the people who are really good at doing this, the true iconoclasts and the true innovators, have kind of this natural ability to put, to keep at least at bay, what popular opinion is or what other experts' opinion is, and somehow come to their own opinion about these things and hold it true. And it is hard, I think. Some people just kind of wall themselves off, and I don't know that that's necessarily the right way to do it. One thing that I have observed, and at least certainly in artists and scientists and technology, where your task is really kind of more free-form and coming up with new ideas, not simply trying to go against the crowd, but actually coming up with new ideas, is particularly the role of novelty. One way to kick the brain into seeing things differently is to take it out of the usual circumstance. So many of the great discoveries, many of the great artistic creations were created in environments that were completely different for the person, or the person was interacting with people they hadn't met. Essentially anything that prevents the brain from relying on past categorizations is very helpful for creating new ideas. I wrote this, essentially my first book was all about this, and I wrote this second book in part because I realized after I went around the first time with talking about satisfaction and novelty, that most people didn't agree with me. A lot of the reactions I got were, I don't like novelty, I don't like doing things differently. And so I thought about that, and then I realized, well, okay, so let's talk about people who do things differently, and those are the iconoclasts. Go ahead. Then.
I have one question. Iconoclasts who achieve some great recognition and success in society, you mentioned that they need to somehow convince other people in there. And it also means that they need to integrate into existing situation and existing opinions. But what do they do inside themselves? Because in order to stand on their own opinion, they need to feel all this fear and being emotionally depressed somehow. But in order to being able to convince people, they need to be on the same wave with them. So sort of accept and being emotionally positive.
Exactly. So you've identified kind of the great paradox of innovation and iconoclasm. that you can have an individual or maybe a small group who comes up with this fantastic idea, clearly novel or clearly superior to something that's already out there. But then how do you go and convince everyone that what you have is better? Because if you accept the fact that I think most people find comfort in what they're used to, then you battle this, right? What I think it comes down to, and I actually start off the book with a story of a guy named Howard Armstrong who invented FM radio. So Armstrong's story, very briefly, he invented most of the radio technologies that we use today. He invented key technologies in AM, but he spent 10 years developing FM radio because he believed it was far superior to AM. And what happened, the story of Armstrong was that he was friends at the time with David Sarnoff, who was president of RCA at the time. This was in the 1930s. And RCA had put an antenna on top of the Empire State Building and was broadcasting AM all over New York. And they were heavily invested in AM. And Sarnoff essentially hired, groups of engineers at RCA to discredit Armstrong, even though Armstrong and Sarnoff had been friends for a long time. Hired mathematicians to disprove him. But Armstrong stuck with it because he was convinced that FM was better, at least in terms of fidelity. And he spent 10 years on this. He built prototype. He did this amazing demonstration where he transmitted from this little shack in New Jersey to a receiver on Long Island, essentially skipping over Manhattan. And for the first time, people were actually, they did this demonstration where they crumpled up paper in the studio and people could actually hear this. And they poured water in a glass. And you can't do this with AM. It's just, the fidelity's not there. And still, it wasn't enough to convince RCA to buy the technology. And what happened was Armstrong became very depressed about it and eventually committed suicide over this. So it's somewhat of a cautionary tale because it points out that you can be absolutely right. You can invent something that's better. But if you can't get other people to believe you, then it might as well not exist. What this comes down to is social intelligence. And did Armstrong have it? Probably not. I mean, he probably wasn't that great, with people. And so the issue is, can you learn to be socially intelligent? Maybe a little bit. I talk a little bit about this in the book in terms of what we know about the neuroscience of social intelligence. But, really the easiest solution is to partner with someone who is socially intelligent. That's by far the easier way. Your company here is a great example of that. The partnership between Bill Gates and Steve Ballmer. You've got, kind of one person who's had, the great ideas, and then, initially the other person who was, fantastic at selling it and getting other people to buy into the idea. Sometimes it does take a team, and taking elements of these different things. But it is a fundamental problem. We can talk a bit about kind of when you target an idea, who do you target the ideas to? I mean, there's an extensive literature on diffusion of innovations that talk about this in terms of who are the people who are what are called early adopters. Who are the people who are more likely, to accept in a new idea, and who are people who come along later in the later waves. I think early adopters are kind of a very small subset of the population who have probably higher levels of dopamine. You might be talking about younger groups, younger demographics. And there's a lot to talk about there. But thanks. Did you have a question in the back?
I was just going to ask, so is conformity bad? And should we all be iconoclasts?
Well, so this is like the same question before. It's good until it's bad. The problem is can you recognize when it's about to go bad? That's the real challenge. I mean, if I had to say on average, yeah, your odds are better going along with the crowd. I think that's hardwired into our brains because, if you were this creature, and you didn't know where to forage for food, and you saw, a bunch of other animals kind of going off one way, well, odds are they probably know something you don't, so you follow them. And I think that's a statistical fact, and very early on got built into the evolutionary process, that animals that tended to follow the herd probably on average did a little better. And that's in our brains. And so, I mean, but the challenge is really, how do you break out of that and limit that? Not an easy answer. So.
I'm interested in the neuroscience behind like really extreme cases of social proof. Like we have the saying, drink the Kool-Aid, right?
Yes.
Which came from the Jamestown event where people were willing to knowingly drink poison instead of not being part of the group. Are we so socially hardwired that, we should kind of be afraid sometimes? Or?
Yeah, you bet. I mean, the thing that's weird about it, every time stuff like that happens, you can sit here and say, well, I wouldn't do that.
It's clearly not rational then. But not all of these people weren't, these were just people, right?
Yeah. That was what that's why Ash did the experiment, because, we can sit here kind of in a very neutral setting and say, well, I wouldn't act that way. No way. I would stand up for what I believe. But, it's not clear to me that is as strong as we believe, and I don't think it is. I think, that's why we did our brain imaging experiment. And if it were simply a matter of willpower or courage, I could accept that and say, well, yeah, maybe I might be too afraid to stand up. And, maybe certainly that was going on in the Kool-Aid thing too. But if you accept the possibility that maybe it's not even that, maybe it's just that, when we see a large number of people doing something, it actually does change how we see things. And I think that does operate too, and kind of the pervasiveness now of kind of 5-star rating systems, everywhere you look. It colors how we value things. We have an experiment going on right now with teenagers and using clips from MySpace and the effect of these 5-star ratings. Does it actually, if you see something 5 stars on Amazon or YouTube, do you actually like it more because it's 5 stars? Possibly.
Yeah, you had mentioned that iconoclasts might need social intelligence to have their ideas accepted, but it seems like the opposite is true, that societies might have iconoclast intelligence. Like, I think that the ability to welcome innovation varies over time, and you might have a culture where innovators are sought out or rejected, depending. So that was one thought. Does that seem?
That's a good point. I actually hadn't thought of that.
Because societies
Yeah.
tend to optimize as do individuals.
Yeah.
My other thought was with and this kind of it relates to the first thought, but with the RCA example, with this guy who wasn't able to sell his ideas to RCA, it seems that if there had been a healthy competition there, maybe there were 3 or 4 or 5 stations that were doing the same thing, you could imagine that his ideas would have been welcomed pretty quick.
Right.
Maybe not at RCA, but maybe at a competitor.
Yeah. No, you're absolutely right. The context of innovation, depends kind of on the background noise, and the context
It seems
is.
like healthy societies encourage, basically are healthy because they get rid of this blindness that you get when people act as herds. I don't know, just the thought.
It's hard. I think it's easy to say that kind of after the fact. It's not so easy, kind of when you're in the moment on kind of how you strike the balance. I think that's exactly the situation we have right now with the finance markets that, the government's going to struggle with, and how much regulation to put down on it or not.
Maybe one more question.
Okay. Yes.
Yeah, I was wondering about you mentioning how dopamine has changed in our perception of it, and Jeremy Bentham, who I remember from his moral calculus, that we're trying to figure things out, if it makes moral sense or not for us to take this cab or not. And I take it that's not where you're going, but the reason you changed, or discussed dopamine is so it doesn't have as much an effect as a reward effect in this calculus. So if it's a calculus, you bring up Bentham because it is a calculus. Are you trying to basically change the nature of what we normally would think is dopamine is that role in that calculus? And
Well,
therefore, there's not a reward aspect to it there?
No, the reason I spent so much time on it is that the role of dopamine, it clearly is related to value in the calculation of decisions. But my point is that it's prospective. It reflects a person's belief about the future. It does not kind of necessarily reflect kind of your instantaneous utility and reward, when you get it. The brain it seems very clear is that the brain discounts the future very quickly and efficiently. So if you make a decision to purchase a book, and you're anticipating the benefits of that, you get the dopamine spike at the moment, that you're trying to go through the calculation of whether you buy it or not. You will undoubtedly kind of discount it so that when you actually get the item, it may or may not meet your expectations. If it meets your expectations exactly, you don't get any more dopamine out of it. You've already had your dopamine kick.
So then for the folks who are, I like the amygdala, it seems to be the maverick part of the brain along with arousal. So, is that can be also be tied, one can train oneself to get a dopamine anticipation when you feel like you might be a maverick?
Yeah, well...
Is there a profile, I guess? Is there an F-scan the profile of the maverick brain?
Well, I come back to novelty again for this. So when you're in a circumstance that you can't discount the future, meaning you can't necessarily anticipate the future very well, or your predictions are quite poor, that's when you're releasing these neurotransmitters. That's, everything is new, you have to do a new calculation, and that's probably when you're getting most of the dopamine release. You're probably also getting amygdala activation too at the same time. It's these circumstances that you're in a completely new environment that's a little bit anxiety provoking, but it's also kind of highly arousing. I mean, kind of physiological arousal and stimulating. That you're kind of getting both the dopamine and the amygdala. But those are exactly the circumstances that I think foster creativity. The problem is that if you're sitting kind of in a quiet state like this and you're given the choice, do you want to go out and do something new? Do you want to go do something completely different? Maybe it won't work, maybe it will. Most people will be conservative and not take the chance because they exaggerate the downside more than they probably should. And that's
sort of what Plato said in the dialogues, right? When he said the only way you really learn is to remember. The only way you remember is to get yourself in the state of aporia, which is that confused, I don't know where everything is, and that's the time where you go actually learn something.
right. I agree. Thank you.